Hello, my name is Gregor von Laschewski, and I'm teaching a number of courses this semester at Indiana University. And this course covers E516. The other courses are 616 and I524. We will be discussing within this lecture also the differences between these courses. All communication to the courses are being conducted via Piazza. The appropriate links are being posted here on the first slide so that you can easily locate them. I would recommend to do a bookmark as part of your web browser so that you can easily find them. However, you need to be first enrolling into Piazza, and that's best done via Canvas. So you go to Canvas and then you click the Piazza link in that particular class, and then it asks you to enroll, and then you can enroll. There are some additional information in the handbook about what you have to do in case you have already enrolled in Piazza before, so that should not be an issue for you. Overall remarks to the class: we will be using GitHub for all artifacts that are being developed as part of the class, because we are trying to use open source software and develop actually open source software as part of the class in a collaborative fashion. This also means that the GitHub that we will be using will be open for everybody, and the license that you will be using for developing your programs is an Apache license. Cloud technologies that we will be using include Docker, Docker Swarm, Kubernetes, OpenStack, and students must have the option, or students have the option to use AWS and Azure, but we are not offering them for free to you. You have to just go out. Typically, students get a free student account. And the reason why we do this is we have learned from past lessons, past semesters, where students simply abused this system and used up many, many thousands of dollars of compute time. And we don't want to have that happen again. The class material is this year consolidated into a handbook as well as 6 volumes. And this is based on a lesson that we had over the years where we only had an online version of this class available, but because the material that we have is somewhat extensive, we were being asked by the students to distribute them as in book form, and this is what we are currently doing. So instead of keeping the website up to date, we keep the handbook up to date and post on a weekly fashion updates to the handbook onto our link, and you can download this handbook weekly. This then allows you to use this handbook either on a cell phone, tablet, laptop, or desktop. And naturally, cell phone, excuse me, a cell phone is a little bit problematic because there's not enough space on most cell phones. So I recommend to use tablets, laptops, or desktop for this. The handbook currently has 700 pages, from which we have released about 500. Additional bibliography for the book is one of the things that Indiana University encourages in every class is that beyond the material that is being presented in a book, we are actually supposed to be learning the material of the topic. This means that a book may not necessarily be the only source of your information that you need to be consulting, not even the books that we just here recommend. And what you need to do is in our case, because the field of cloud computing and big data is evolving so fast, you have to use clever Google searches in order to identify more information. You also have to identify which information is advertisement and which information is real. In addition to the web, we also encourage you to look at the Gartner reports, and we will be integrating the Gartner information into our class slides. This includes access to leading edge industry analysis, such as the hype cycles that Gartner produces. We will actually show you how to access those in class and provide section in the handbook when time comes. Furthermore, we are recommending a book that's called Cloud Computing for Science and Engineering by Ian Foster and Dennis Gannon. This is a very introductory book with some very small examples. We will, in our handbook, go in a much more detailed fashion into some of the cloud aspects. However, this book covers, for example, Amazon and Azure access of clouds, so it's really valuable for you to potentially look into. So this is good. Naturally, some of the information could be replaced by web content that you are looking up yourself. On the serious side, the book gives a fairly good introduction about the different aspects of cloud computing. More importantly, we actually have put all the information, or will put all the information from the class into our handbook. This handbook will evolve over the semester and being updated on a weekly fashion. Additional volumes contain student work that has been contributed either as papers or as project reports. And we get often the question is, well, can you give me a good example for a paper? Can you give me a good example for a project? We would like you to browse through the volumes and through the projects themselves that we have published and identified for yourself what is actually a good project and what is a good paper from the list of papers that you have. Not every paper in these volumes has received an A, and we will not really reveal which ones have or have not. So you will be able to identify fairly easily which ones are wonderful papers. Additional drafts include additional volumes, and there's one paper, for example, in the 6th volume of this that's listed here on the bottom in spring 2017 that has been actually published in a workshop. And so the student has done fantastic work, which was actually a student who worked alone. So you can see this easily, and I think it's easily identifiable which paper that is. And the other remarks are for two other classes that we are not concerned of in here. The nice thing about the management of this is everybody can contribute in chapters or improve existing chapters to, for example, spelling errors or something like this. And for this class, we want to communicate via Piazza, but if you are not participating in the class or if you are a community member, you can get in contact with me via the email that is being specified. The handbook is hosted at the link specified here, and the PDF is hosted in abbreviated form on a Google Drive, so you will have to download that particular PDF document in order to make use of the hyperlinks that are being embedded in the document. So don't just go out and browse this in your browser, but just download this and open it up as a PDF document. For this class, this is actually the 516 class. We have a tag that's called E516. But for the other class, we have an E616 or an E222, whatever the class is, we have a branch for you. And the I524 class shares the same branch as the 616 class. We will be managing all of this through GitHub, and it includes documentation and also videos. Video lectures are embedded in that document, so you can click on the video link as well as the presentation links, and you ought to be able to see all the lectures that we are distributing this way. As said, this is as we release the lectures on a weekly basis. You will be seeing weekly updates to that document, and I recommend to download the PDF so that you can make use of this. As the document is downloaded weekly, make sure that you don't confuse all the downloads with the ones that are currently up to date. For that, we have included a timestamp on the front page of the document. Conventions that we actually have that make things fairly nice for you. We have an extensive table of content and an index with page numbers that allow you to navigate easily in that document. Hyperlinks, as you have heard already previously, are embedded. It includes documents, videos, slides, web pages, citations, and page numbers in that index. We have special notations that include boxes that are included within the text that emphasizes notes and warnings that we want you to be explicitly aware of, but also some IU-specific topics that retain to just Indiana University. And so I would also pay attention because you guys are here from Indiana University taking this class. Exercises are clearly marked, and I suggest that you do the exercises for your section, but you're also welcome to do others, but you may not get credit for the ones that you do in addition. However, I recommend to do some of these exercises as your experiences grow, and you can certainly do this on your own leisure. However, when you do any exercise, please be aware that some of them may actually take weeks and not minutes to finish. So be careful that you spend time on the class deliverables first, and then go to exercises that may help you doing some other things. I recommend that you are not printing the content of the document, as the content will change. So this PDF document would be best off on an iPad or a tablet or your laptop, and then you browse online through it. But certainly you can print it out, and we will be having a section in that document that clearly tells you what the important parts are that are being updated. We will not notify you if there's a spelling error being changed, but if you, for example, add an important hyperlink, or if we add an important section, then we will be putting that in the update section, including the page reference number where this update took place. So it's easy for you to reprint some of the pages. Topics that are covered in the handbook include the class management. That's what we are currently talking about. How do we collaborate? How do we do scientific writing? How do we do development? Python is a big part of the class. Introduction to cloud technologies, and also for the other classes, big data technologies. And cloud and big data technologies are very tightly connected with each other, and we will cover both of these topics. There will be links to theory videos that we will be releasing also on a weekly basis. At this time, we haven't released any theory videos, so please be patient. We do this on a weekly basis, and it will be clearly marked with a check mark when the video is watchable in the appropriate section. The other thing is we will be going through some of the volumes that include applications in cloud and big data, as well as technologies in cloud and big data. And we will be expecting that you identify new applications and new technologies as part of this particular class in order to fulfill the IU requirement for classes, that you are not just listening in a graduate class to someone talking, but that you are actually doing active engagement into this topic and furthering your knowledge into that topic, showcasing that you can independently do that. So you are invited to contribute to anything here, including grammar, chapter, and sections that you would like to add, or tutorials that you would like to add to the book. We will be acknowledging you appropriately for that. The syllabus of 516 is as follows. We have to be reminded that because of the topic, this is different than a physics or a mathematics lecture that is of a more classical content, because our content has a tendency to change rapidly. And in order to accompany this, we will be giving you a relatively well-established syllabus with the topics that we discuss. But in case we were to discuss, were to identify some additional things, we may change the syllabus slightly in order to add new topics that we haven't considered or that were not available at the start of the class. As part of the selected topics, we will be developing first a REST service. And that REST service, we will be introducing the theory and practice. And we will be using an open API standard in order to develop that REST service to auto-generate a variety of clients and servers. And we will be focusing on a Python client and server. In addition to that, we will be asking the students to develop, based on the National Institute of Standards development work that I'm participating in, to identify objects and REST services that are useful to implement a big data reference architecture. In previous classes, we had more paperwork. Here we have a little bit more practical work. So this is a defined assignment which probably takes a month. It could also take longer, and you could take this into your final project actually. The second topic that we will be talking about is an introduction to clouds and how REST services are participating in that activity. And this includes mostly the creation of how do we start virtual machines and start them. And as part of, we want to run something into that virtual machine, we will be using our REST service that we have developed in the first part to start up that REST service in the virtual machines. Clouds these days are more than just virtual machines. We are and this is a very new recent chapter that we are adding. We are giving you also an introduction to containers, and explicitly here we will be focusing on Kubernetes. And we will be using again our REST service to showcase how that particular service can be integrated in Kubernetes, and you can run many tens or even many hundreds of REST services next to each other in, for example, such a Kubernetes environment. One of the more traditional activities is actually Hadoop. And when we are being asked about cloud computing, we are always being asked about Hadoop, and students want to learn Hadoop. So we will be having a chapter about running Hadoop in the here as part of the class, and we will be practically focusing on how to run actually Hadoop in a container, and then also see how can we use this into, or how can we run such Hadoop services in a cluster. The last topic that we will be addressing is edge computing, where we integrate sensor data into cloud services and REST. And a previous student who is actually online today, we will be converting his contribution into a chapter in this particular handbook, and make what he has used last semester as a project. We will be using this as teaching material. So this is a really good honor for the student that he has achieved that. There will be some additions from my side to this particular chapter, and I will be co-writing it with him. Here, because the student is still in class, he can use this particular effort as his paper number one. Outcomes are naturally, we have an elementary understanding of the issues involved in cloud computing. We gain hands-on laboratory experience with creating clouds and managing clouds. You can apply your knowledge of mathematics, science, and engineering that you bring in from other fields into this cloud, while, for example, issuing that as part of the REST service that we are developing. we gain a deep understanding about the challenges and the issues that we have when we define a software-defined system. We will have advanced skills as part of teamwork. We hope that you are working in teams, but you can also work individually, especially online students sometimes benefit from working individually as they may not know their partners. So you will have to make a decision if you want to work in a team or not. Teamwork naturally has the chance that you have someone to discuss things more frequently, but that team needs to have time to collaborate with each other. So make sure that that is being clarified at the beginning. Naturally, at the end, you have not only practical knowledge, but also theoretical knowledge about all of these areas so that you can communicate this to others. We are teaching this in parallel tracks. That means we have communication track, we have a theory track and a programming track. All of them are actually starting at the same time. And in communication, we use Piazza and write a paper. In theory, you learn about all the different topics. And in the programming, we are using predominantly Python. However, if you are having a project that wants to use, for example, Go as a language, we can accept that. If you want to emphasize on Hadoop, we can also use Java. But Python has the advantage that even you can do Hadoop in Python. You can interface with your Hadoop cluster. And Python has the advantage to be very popular in big data. The topics of E616 include a similar trend, and I will be explaining this here because you may want to know what the difference is between 516 and 616. And here we have the same topic, and we are starting out with the REST service and develop the REST service. Then we are using a multi-cloud interface and developing that and tell you what actually a multi-cloud is rather than a single cloud, where we can submit virtual machines not only to a single OpenStack cloud, but maybe OpenStack and Amazon and Azure and so forth. And we will develop a program that actually does this for us. Just as the previous class, we will be looking into Kubernetes and containers. But in the class E616, we will build a physical cluster out of Raspberry Pis within the residential class. Online students are free to do that too, but they don't actually have to do this, the online students. But if you have the financial ability to buy yourself 3 Raspberry Pis, then you can follow us. The residential students will be building a cluster with 5 Raspberry Pis. We have altogether 50 Raspberry Pis, but we will also get another cluster for 150 nodes so that we can do federated Kubernetes as part of the activities that we are planning to do. Then in 616, which is also partially done in 516, it's very important that we look at new trends. That includes theory, and that also includes identifying new technologies and trends for cloud computing and big data. For example, we will be looking into the Apache software stack, and if you look into the incubated projects, you may see maybe a project called OpenWhisk, and we need to have you analyze or identify a new trend or new technology that you then contribute to our volumes and to our handbook, so that we make sure we are not missing something. Because, as I said, this is the development time of the activities in cloud and big data is so rapid that even throughout the time we are teaching the class, new things will happen. A good example is the current bug in Intel, and how to address something like this or identify something like this. Just as the other class, we will do edge computing, And one thing that we will not do in E516 much is cloud DevOps, where we explain how do you manage a cloud in such a form that it's automatically being generated. That's one of the things that we are addressing here. Because we have so many topics, I hope we can cover all of them. The last one we may not go into too intensely. Outcomes are naturally clear. You're an expert in these areas after you have taken the class. You have an understanding of what software-defined systems is and so forth, just as the previous class. We have the same parallel tracks that we have in 516, just that some of the topics in theory and programming are slightly different. The most important policy that we have within the class is what I term R2D1. Remember, there's an R2D2, so you can actually remember that very, very nicely. And this is referring to read and reflect and do once. That means sometimes we are providing information, and because of the nature of computers are evolving, and the tutorial or the tutorial that you find on the internet may be outdated or may not exactly give you the right configuration for you to do. But that's unavoidable. You cannot change this. That's the nature of computer technology. And so what we want you to do is not just paste and copy the words, but also read and reflect first what you need to do. Once you have reflected and thought about this, you do it once, and therefore we do the abbreviation R2D once. So read, reflect, do once. The most important other thing that we have as a policy is before you do anything to your computer, make sure that you back up your computer. Other more general policies include, well, mind the university calendar. The course starts today and ends at the last day of the semester. We are using Piazza, not Canvas. Use the class material and read it, as previously pointed out. We will be assigning you an HID, that is a homework identifier, and the TAs will assign you this within 1 week, and so that you don't have to use the IUID with us, because we consider this as confidential. Don't ever send us the IUID. Office hours with the TAs will be announced, and that will be hopefully done by next week. Self-reporting is important because we require you to maintain a notebook.md file as part of your GitHub, and in that you just write down weekly what you have done in bullet form. We are the university is very strict in plagiarism, and we as teachers do not have another choice but to follow the guidelines and the policies set for plagiarism within the university. I have put together a new chapter into the handbook that teaches you about what plagiarism is. And this chapter is actually a copy of information that I found from Indiana University. And in order not to plagiarize, I've clearly pointed out that this is a copy. So please view this as an example, not as an example on how to write a chapter, but view this as I need to read this chapter to figure out what plagiarism is. Assignments are announced. Most of them will be done in Python. So it's useful for you to get started or refresh your knowledge in Python. But we have a section in the handbook that is sufficient for you to learn Python and to use it as part of the class. So if you don't have used Python, don't get in panic. Just start working on this. We will be writing a meaningful REST service. The multi-cloud shell we will be doing in another class, so we will probably not do this here, but we will be doing other things in Kubernetes so that you get familiar with containers. So the focus is clearly based on cloud computing via virtual machines and containers. And remember that when you do projects and assignments, they may not take minutes, but they may actually take weeks to implement. And if you were to come on the idea to do the paper or the assignment the day before the assignment is due, I think you will be seeing that's not a good idea. Rather than that, I would use an incomplete for that assignment, and you get a great deduction for the incomplete. But in reality, you have enough time because the assignments are given early to finish the assignments in that given time frame. Just spend enough time on the class. Grading, because this is in contrast to previous classes, we have reduced the grade for projects to 50% and emphasized the assignments a little bit more to 40%. And the participation will be 10%. We will, in principle, not have any exams, any graded exams, because we have assignments that we pay more value on. There's one exam that is, if you want to get access to OpenStack Cloud, that you must pass. And it's essentially our driver's license to get access to OpenStack. Assignments may be added based on class performance. That means if we identify that the class has an issue with something, we may elect to add an additional assignment on this so that all of the class can look into this. As mentioned, we will not have exams. And the other thing to be reminded about is don't assume that because we don't have any exams that you don't have anything to do in the finals or midterm week. That is wrong. You actually do have deliverables that have to be handed in during that particular week, which includes typically papers and reports. And it would be wrong from you to ignore that particular time needed to prepare them. But you should prepare them well before that midterm time. And if you want, then you can then naturally spend time on other things other than your paper. So this will help you out. We are using Piazza instead of Canvas because of its superior communication capability for this particular class. And we have given that recommendation by Indiana University professional educators. And they recommended us to use Piazza when we discussed how we are interacting with the students. And I'm glad that we follow their professional advice. It allows the students and instructors to work essentially on a single answer. So when you do a new post, you can see there's an instructor answer and there's a student answer. And you will be able to contribute to the answer. And this is how you can earn discussion points by answering other students' questions. Canvas we have experienced, and this came through some discussions with others, problematic interactions because it doesn't foster the goals that Indiana University sets to engage students in advanced answering processes as such as being provided by Piazza. So we really like that mechanism, and we put that to work. In addition, recently I had to work with Canvas quite a bit, and due to some plugins in my browser that are being used for everything else, and they're working beautifully for everything else, but not for Canvas. And for some reason, in some cases, you're working for an hour long on an answer in Canvas in an email that you're sending to someone, and the message simply vanishes. It's just not goes away, and we are losing the entire content. And I'm not sure if this is something with my browser or if there's something with the backend Canvas that it doesn't save a draft, but I've never experienced such a thing in Piazza, so therefore we are using Piazza. In order for us to make Piazza work, students must participate, instructors will guide, and we are not using any email messages to either privately between instructors or to students. So we just have everything in Piazza so that there's a record there so that we can make sure that all instructors know about the answer. The way this typically works is the student participate in identifying questions and answers. You will be identifying answers. Then the TAs will help on the answers. And if I detect that there's something that needs to be corrected, I will be adding corrections to it. So this will be giving a wonderful way of you being able to earn some discussion points. But certainly there are cases where the answers, I'm probably the only one knowing about the answer, and so I will be going into and answering this. I hope by the time I come in, we have already a preliminary answer developed. The instructors will be curating the Piazza and remove, once things are done, all unimportant things such as thank you or unimportant content that is inappropriate from the Piazza posts, and make sure that we have them cleaned out. A good message in Piazza is as follows. You select first the instructors field. If you want to do a private post, you can naturally, and you're super encouraged to post your question publicly. That's really the best feature about Piazza. Then you select the folder where your questions may be, and you will put in your HID, which will be assigned to you by the end of the week. And here's an example for a question that is being given by someone, and you may actually end up with an answer is like, well, this is being already discussed in the handbook, and so you should not be feeling bad about this, that you have overlooked this. You should be feeling, oh, this is really good. I can find the answer in the handbook, so let me go back. So don't come back to us and simply say, we are not answering your question. Actually, in fact, we do answer your question because the answer may already be posted elsewhere, and we give you the link to where it's being posted. Because the handbook may actually change, it's not a good idea to post page numbers or section numbers. Instead, use titles or maybe keywords. Look up the in the index, Chromebook, and you may find the answer to there. For the first week, we have an assignment. You are supposed to be posting your bio in Piazza. This is going to be our test to see if you are in Piazza and have been able to post. And we will be sending out a survey that you need to be filling out, and you need to be answering all the questions from the survey. They are related towards your computer equipment for the class to make sure that you have sufficient compute power to conduct the class. And if not, we will be identifying alternative compute power through online resources that we will be able to let you have. In week 2, which is not yet mentioned here, there will be an additional homework, so you can already look into this. The biography will be converted into GitHub, so we will be uploading, once you get your GitHub folder, the bio into Git, and the TAs will be creating a script that puts all the bios from all students into a single document that will be part of our next proceeding, because as a result of this particular class, you will have a proceeding created. I have another lecture about the introduction to clouds and so forth, but I feel like that this may actually be a little bit too much for today, and we will run out of time. But if there's still time left, I will be going into this. This essentially completes this particular lecture, and I will be trying to identify how to